Hi everyone, can you all see the whiteboard?
Yes.
Okay. What answers did you get for the first question? Okay, good. All are correct. 95 is the right answer. Ahana, can you explain?
Okay. So I found the average of her 5 test scores, and I added them all up and divided by 5 because there were 5 tests, and I got 77. And 77 plus 3 is 80, and she needed 3 more points. She wanted to raise her test average with at least 3 points with her next test. So I tried to add since the sum of 90, 80, 70, 60, and 85 is 385. And I tried out different numbers to see if and then I added different numbers and then divided those numbers, the sums, by 6 to see if they would equal 80 or more. And the answer I got was 95.
Good. Yeah, so this works. So there's this for this last step, there's a few ways of doing this. So one is you can look for numbers that will then average to 80. Otherwise, you know that if the average is 80, what should the sum be?
The sum of all 6 tests should be 480.
Good. So you know 385 plus the last test score, let's call it x, is 480. So x would be 480 minus 385. So that's another way, and then you can confirm this is 95. Now there's actually a third way that you can kind of do this last step. Any other ideas of ways you can do this? Okay, so let's think about, so the first step is we got the average to be 77, right? So let's think about if the original scores were 90, 80, 70, 60, 85, we know the average here was 77. What happens if she gets a 77 on the last test? What would the average be? It would stay 77, right? If you had an average of 77 on the first 5 tests, score 77 again, it'll stay at 77. Now, if I want to improve the average by 1 point, now this means the sum needs to increase by how much?
By 6?
Good, because there's 5 original tests and 1 more test, right? The sum needs to increase by 6. Now these 5 of the test scores are remaining the same, right? They're constant, they were previously done. Only the last test score can kind of change now and increase. So if I need to increase on the last test the average by 1 point, this has to increase by 6. So what do I need to do if I need to increase the average by 3 points?
Increase by 18.
Good. Yep. So then if I increase it by 6 points, I know the average increases by 6. So I know the sum increases by 6, so the average increases by 1. If the total increases by 12, then the average increases by 2. So similarly, if the total increases by 18, the average would increase by 3. So 77 plus 18 gives us also 95. Does this make sense? Any questions on this? Okay, let's move to the second one. Nice, a lot of answers today. Let's see, Preeti, can you explain?
Yeah. So We know that every 3 is equal to 30. So you know that a plus b plus c is 30 and c is 5. So to find b, you'll know to do 25 minus a. And then that kind of continues for the next few. So like for b plus c plus d, you know that d is equal to the same value as a, and then still know that c is equal to 5. And then you keep on using that pattern, then you get that you kind of follow the same thing. So for the next 3, e is equal to 25 minus a, and then f is also 5, like how c was 5, and then g is equal to a. So finally, you can see that h will be 25 minus a. So then to find the actual a plus h, you can just use the terms of a plus h of how you found it, like how things were like 25 minus a. So you can just do like a plus 25 minus a, and then that all cancels out, so you get 25.
Good. Yep, that's correct. So yeah, the key idea here is that you know first that c is 5. So the third term is 5. And what did I write? C is 5. Sorry, this should be c is 5. You know c is 5, and any 3 consecutive terms sum is 30. So if you start with the first 3, okay, you know c is 5. So this means a plus b is 25. Now let's write it as a is some number, b is 25 minus a. So you know a, 25 minus a, and 5 are the first 3 numbers. Now you know the next 3 also need to add up to 30. So 25 minus a, 5, and so then the fourth one also has to be the same as a, so that these 3 add up to 30. And similarly, the pattern will repeat. The next one would be 25 minus a. The 25 minus a plus 5 would be 30. The next one would be 5. 5 plus 25 minus a plus a would be 30, and so on. And we see that the neat thing here is that h actually ends up being 25 minus a. So 25 minus a plus a is 30. 25 minus a plus a is 25. And we actually didn't need to know what the value of a is at all. So a could be any value, b would be 25 minus that, and so on. And this sequence could be filled in many ways. But a plus h will always be the same. It'll always be 25. Does this make sense? Any questions on this? Okay, let's move on to the last one. Good, 43 is correct. Sanvi, can you explain?
So they tell you in a triangle with integer side lengths, one side is 3 times as long as the second side, and the length of the third side is 15. So one of the sides of the triangle will be 15. One side will be x, and the other side will be 3x. So in a triangle, when you add up any 2 of the sides, it should be greater than the third. So it should be greater than the third side. So in this case, 4x should be greater than 15. 3x plus 15 should be greater than x. And 15 plus x should be greater than 3x. If we take 15 plus x is greater than 3x, this means that 15 has to be more than 2x. Because if you divide 15 by 2, you get 7.5, and the closest but smallest integer to that is 7. So if you take x as 7 plus 15 is 22, and 22 is greater than 21, or 3x. So if we plug that in, it'll be 7 as x, 21 as 3x, and 15 as the third side. And if you add 7 plus 21 plus 15, you get 43.
Good, yep, that's correct. 7, 15, and 21 would be the 3 sides, with a perimeter being 7 plus 15 plus 21 is 43. Okay, good. Now, you used one property here that the sum of 2 sides must be greater than the third side. Do you know what this kind of property is called? Anyone? Okay, it's called the triangle inequality. And it basically says that if you take a triangle, the sum of any two sides must be greater than the third side. Why is this true? Any ideas?
Because if one side is greater than, or sorry, because its sum of any two sides must be greater than the third side. If it's not true, then it cannot become a triangle, like the points cannot connect.
Good, yep, that's correct. So there's ways of formally proving this, but let's look at a pictorial kind of example. So let's say I have this side is, let's just pick two side lengths. And let's say this side length is 4, this side length is 7. Now, right now, this third side length is going to be something, I don't know what it is. It's some number. How would I make this bigger, keeping the 4 and 7 the same lengths?
Maybe if you move the angle with the 7 and the 4, if you move the 7 a little closer to the 4.
Okay, let's see what happens there. Okay, so let's say I move this closer. Do you think that would become smaller or larger? This side.
Could you repeat your question, please?
Sure, yeah. So now I made this angle a little bit smaller, right? So now what happened to this third side? Did it seem like it became smaller or larger?
I think it became smaller.
Yep. Okay, so how do I make this third side larger?
You would have to make the angle bigger.
Okay, so let's try that. So let's start making the angle bigger. So as we make the angle bigger, we can make this third side bigger and bigger, right? What's kind of the limit of that? Can we just make it like 1 billion? Can we make it 1 million? How big can we make this third side?
You can make it to anything less than 180 degrees.
Good. So what happens when it's actually 180 degrees? Or let's imagine 179.9 degrees. So what would that look like? Something like, sorry, I should have kept this the same. Okay, this was 4. Let me try to keep it the same approximately. So we move it to something like this, right? Okay, so this is 7 and 4. And now this third side is something like this. How wide is the third side right now, approximately?
Approximately 11.
Good. So imagine this angle has become almost flat, right? It's not fully 180 degrees. It's a little bit less than that. You can imagine if this was 180 degrees, right? This becomes a straight line. This becomes a straight line with this. And we know the full thing is a length 11, right? It's one line then. And this third side then would be 11, right? If that was a possible triangle. So that essentially becomes a degenerate triangle where it doesn't really exist anymore because it has no area in between it, right? You just have a straight line. But if you imagine that angle was very, very small, this third side will be close to 11, but not exactly 11. So what did that tell us? This third side, what is its range?
From anything less than 11.
Good, which is the sum of the other two sides, right? So that's all we're saying here. The sum of any two sides must be greater than the third side. Because if the sum of two sides was equal to the third side, then we became this case, right? Where the two sides essentially became a straight line and the third side is essentially the same line. So it's not really a valid triangle anymore. Does that make sense?
Yes.
Yes.
Okay, good. Now let's just think about the other case for a second. So how small could we make this side? The third side here. Can we make it 0?
No, that
Why
won't.
not?
Because for it to be 0, then the angle would have to be 0, and then that would just be a straight line that wouldn't even, like, it would
Yeah.
connect.
Good, yeah. So we can start, to make it smaller, we can start imagining this angle becoming smaller and smaller, right? So let's imagine what happens when this angle becomes 1 degree or very close to 0 degrees. What does the triangle look like there? So this would come closer to something like this, right? So what does this third side become equal to approximately at that point?
Approximately 3.
Good, why 3?
If we picture it like as it's shown, then one side 7 and that smaller side 4, they need to connect the gap between. That would be a length of 3.
Good, yeah. So essentially you can think about it became a line in the other way, right? Now the 7 is one side. If this angle is exactly 0, then the 4 is basically on top of the 7, right? So the remaining would be 3. But if this is a tiny angle in between, then this is 4, this is going to be a little bit more than 3. Now, we actually hit the triangle inequality again, right? And how is that the case here?
If you add up 4 plus 7, it's 11, and 3 is less than 11.
Good. So now the smallest possible value of this side here, if it's less than 3, or if it's equal to 3, then the sum of these two sides, 4 plus 3, is equal to 7, right? Which again violates this, right? So this side must be at least 3 in order to be more than 3 plus, or whatever this side is plus 4 needs to be at least 7 or more than 7, so this to be a valid triangle, right? So basically when you have two sides being fixed, the third side has to be somewhere between the difference between the sides and the sum of the sides. In this case, with two sides being 4 and 7, the third side has to be more than 3, but it must be less than 11. And you can think about it by just imagining what this triangle would be in the extreme cases with an angle of 0 and an angle of 180. And then you can imagine kind of taking this to the extreme right here and see what kind of happens in both of the cases. And that's essentially showing us that this triangle inequality must be true. The sum of any two sides must be greater than the third side. Does this make sense?
Yes.
Okay, good. Yeah, so this is, I mean, I'm not giving you like a very formal proof, but at least you see the intuition of this. So if you're trying to remember what this is, just think about how, or what this inequality should say. Think about a triangle if the angle between the two sides is very close to 0 and very close to 180. And what is true about the side length there? And this is what the triangle inequality gives. Okay, so now that we have the triangle inequality, let's get back to the original problem. We know that the side lengths here are 15, x, and 3x. And we want to know what the greatest possible perimeter of the triangle here is. So again, the triangle inequality here is important because let's think about, ideally, if I wanted to make it large, I could just pick x as 100 or some very large number, right? But what happens here? If I say the side lengths are 100, 315, of course, this is not going to satisfy, right? 100 plus 15 is much less than 300. You can't have you've gotten to the flat line and have a side of 115. That's not sufficient here, right? So we can't actually have just arbitrary large sides. So this we can think about the triangle inequality and how you apply it here with sides x, 3x, and 15. So we know x plus 3x is less than 15. We know x plus 15 must be less than 3x. And we know 3x plus 15 is less than x. So this one is of course true, right? 3x plus 15, sorry, I switched this, sorry, this should all be greater than. So x plus 15, sorry, 3x plus 15 is greater than x. This is of course true, right? You already have an x factor on both sides. So let's focus on these two. 3x plus 3x is greater than 15, and x plus 15 is greater than 3x. So from the first one, we get 4x is greater than 15. So x is greater than 15 over 4. And from the other one, we get x plus 15 is less than 3x is greater than 3x. So 15 is greater than 2x, and 7.5 is greater than x. So from this, we can see that the largest value of x would be 7, because we know that it has to be an integer side length. Otherwise, if it didn't need to be an integer, you can imagine this being 7.49999, and you could fit that in as well. Because it has to be an integer, we can take x to be 7, and 3x would be 21. Does this make sense?
Yes.
Okay. So one extension question here, what would be the smallest possible perimeter of this triangle?
Would it be 31?
Good. Why?
Because the sides would be 12, 4, and 15. And 12 plus 4 is 16. And that's only one greater than 15, which makes it the smallest case.
Good. Yes. So that is the correct answer. Now, how do you know that 3 is not possible?
Because if it was 3, 9, and 15, it would 12 is not greater than 15.
Good. Yes, that's correct. You can also look at, we just did it in terms of this kind of inequality also, right? So we saw 7.5 is greater than x, but what's the other one? X is greater than 15 over 4. So what is 15 over 4 approximately?
3.5.
Good. Yeah, it's 3.75. So the smallest integer x that would be above that would be 4. So if you plug in 4, 12, and 15, you'd get that the perimeter is 31. So essentially, given this information, the smallest possible perimeter is 31. The largest possible perimeter is 43. And that's just applying the triangle inequality to all the pairs of sides. Any questions on this? Okay, then that's it for today's class. We'll see you all next week.
Thank you. Bye.
Thank you.
Thank you.